This is a video recording of Chapter 1, Section 9 in the 8th grade Holt textbook entitled Solving Equations by Multiplying or Dividing. Let's begin with a quick recap because yesterday we were introduced to, in Chapter 1, Section 8, the rules for solving an equation. And those rules we talked about yesterday were all with addition or subtraction problems. Well, luckily for us, the exact same rules apply to multiplying and dividing. The hardest thing about multiplying and dividing will not be to use those rules because they are the same. The hardest thing about this will probably be making sure you use the right signs and notation when you're actually showing the work for solving an equation. So, a quick review. Yesterday we learned that we can flip the sides of an equation if we need to. And generally we would do that when the variable is on the wrong side, as in the wrong side of the equal sign. When I say the wrong side of the equal sign, the wrong side is the right side because the variable belongs on the left side of the equal side. All right, so you want to keep your variables on the left, which means all your numbers at some point or another are going to have to get kicked over to the right side of the equal sign. Not only can you flip the sides, not only do you want the variables on the left, not only do you want the numbers on the right, but the big rule is when you have to move something to make that happen, you're going to do the opposite. So if you want to move something that's got a subtraction sign in front of it, you're going to move it by adding it then to both sides. And that would apply here now with multiplying and dividing. If we're dividing something, a number out, to undo that, we're going to end up cleaning that up by multiplying. So let's take a look at the first question here, which has been on your screen for a little while. It says 6x equals 48. So we'll start off and apply those same concepts that we did yesterday. And we're going to say to ourselves, okay, we've got a variable that's on the left of the equal sign, x, and we have a lonesome number, a constant 48, which is on the right side of the equal sign. Now, the one difference is yesterday we moved all constants around. Today, because the numbers will be attached to the variable with multiplication or division, we're moving coefficients around. But it still ends up sending all those numbers to the right side of the equal sign, and we're still using opposite side to the opposite. So in this case, I want to undo multiplying by 6. And what they do here to undo that multiplying by 6 is the opposite, which is dividing by 6. And again, that has to get done on both sides. Now, what I want you to notice is how they're showing divide by 6 here. When they're showing divide by 6 there, notice what they're doing is they're showing it like they would show fractions. Because remember, that's what a fraction is. A fraction is just a giant division problem. Like 1/2 really means 1 divided by 2. So the same thing applies here. They're showing it with a fraction bar, which just means division. And that's the proper way to show it. You don't want to come underneath and write a division sign with the 2 dots and the line in between and write that you're dividing by 6. That's just not good mathematical practice is really what it is. Showing that I'm dividing both sides by 6 here with the fractions then. On the left side, the times 6 divided by 6 cancels each other out. Think about if I gave you 1 times 6. You know the answer, 6. And then I said, okay, now divide it by 6. Well, 6 divided by 6 brings me back to 1, where I started. Right? And that's exactly what happens here. When I have x times 6, that's 6x, but then I divide out the 6, and all I'm left with is my variable x, just like in the same way it worked with 1 and 6. On the right side, I've got 48 divided by 6. 48 divided by 6 changes into 8, and that is indeed my solution. We can check it again, just like we did yesterday. 6 times 8 is 48. Since the other side says 48, we've balanced the left and the right side of the equation. Since the numbers match, we've solved it correctly. Okay, let's continue on with the second example. In the second example, they're asking us to solve b divided by -4 equals 5. So we know based on those rules that we saw yesterday, b is okay because that's a variable and it's on the left side of the equal sign. And 5 is okay because it's a number and it's on the right side of the equal sign. What's not okay is negative 4. So we want to undo dividing by negative 4, because undoing it is going to send it over to the right side where all those numbers belong. Now some of you might be looking at this and going, well, wait a minute, how is that a coefficient? Think about this way then, if you want to see it as a coefficient. Think of it as negative 1/4 times b. Well, b written as a fraction would be b over 1, and then I would multiply across, and that would give me negative b over 4, which is almost the same as what you see here. The only difference is the negative is flipped to the bottom side. But think about, for instance, 4 divided by negative 2 or negative 4 divided by positive 2. The answer either way is negative, and the same thing is going to happen right here. Okay, so we're undoing the dividing by negative 4 here. And what I want to make sure you see is how that's actually done. When they're undoing the division, they're multiplying. But what you don't see is an X down here with a negative 4 written on either part. What they do here is they show that they're multiplying both sides with the dot, in this case, by that negative 4, and you see the same thing on the right side. A lot of the time, what you'll actually see are the giant parentheses. Remember, parentheses are another way to show division. So they would put parentheses around things to show that multiplication. As you can now see like that, and would solve from there. Now on the left side, dividing by negative 4 and multiplying by negative 4 cancels each other out. It just leaves me my variable b. On the other side, negative 4 times 5 gives me negative 20, which is my solution. We can check that if we want to. Again, just plug it back in for the variable b. Negative 20 divided by negative 4 does make positive 5. Since the other side says 5 and they match, we know we did this correctly. We'll continue with example 3, which says to go on a school trip, Helene has raised $670, which is only 1/4 of what she needs. What is the total amount needed? One of the operative words here that works for us is the word of. Of is one of those words like product that means multiplication. Now, it really shouldn't be surprising to us that this is going to be a multiplication question, because remember, the heading here was solving equations with multiplying or dividing. We would have been surprised if something would have popped up with addition here. So, she's raised 1/4 or 1/4 of, which is where the multiplication sign comes from, the amount she needs. We don't know what the amount she needs is, so that's the variable x. But we do know that that equals the total amount she's gotten so far, which is $670. So this 1/4 times x is equivalent to 670, which is why they can lay down an equal sign between the two. So we're solving the equation 1/4 x equals 670. Now, notice that this is a multiplication problem. So it's going to be solved by division. But think about it. We're dividing by a fraction here. If you want to see the preliminary steps, we can go through them very quickly, but I'm going to say variable on the left, lonesome number on the right, constant 670. So we see the one thing that's wrong is a 4. That's what's going to have to move to the opposite side. That's what I'm going to do the opposite with. So I'm going to divide by 1/4. Again, I'm doing the opposite because this is a multiplication problem. Well, I've never, ever, ever divided by a fraction. If I give you a problem like 3/2 divided by 1/4, we've never done that problem that way. Think about what we do. We have always flipped the second fraction, find the reciprocal, and we've changed the problem to multiplication. Well, the exact same thing is going to happen here with this example. Yes, I am dividing by 1/4, but we've never done that. So I'm going to end up multiplying by the reciprocal, 4 over 1, which is equivalent to 4, which is why you see them multiplying both sides here by 4. Now, I know it seems it's a little bit odd that we're solving a multiplication problem with multiplication, but that is, again, simply caused by that fraction. We're using the same rules of fractions that we've always used. So on the left side, 4 times 1/4, and it might be easier if you wrote that as 4 over 1, what you see is that makes 4 over 4. 4 over 4 reduces to 1, which is why that whole thing goes away and just leaves me variable x. On the other side, we've got 4 times 670. 4 times 670 is equal to 2680. So we now know, based in the context of the problem, remember the question was, what is the total amount needed? That Helene needs $2,680 to raise all the funds that she needs. We'll continue on with question number 4. Now, question number 4 is in a little bit of a different vein, because what you see in question 4 is you see, yes, we do have multiplication, as in 3x, but we also have addition, as in the plus 2 part. So we actually are going to end up doing both things here that we've learned today and the day before. So at this point, it would be prudent to interject one additional rule for us so that we'll have some success here, because we don't know what to do first. We don't know if I should take care of the multiplication first or if I should take care of the addition first. And I'm here to tell you, you take care of the addition first. And the reason that's so is because the thing with the variable is always what I'm going to touch last. All right? It's kind of the reverse of the whole order of operations. Whereas in order of operations, we do that multiplication and division first and then the addition and subtraction after. In this one, it's the opposite. We're going backwards up the list. We're going to take care of the addition and subtraction first and then do the multiplication and division. Now, if it bothers you that you've got a lot of parts here to start, pretend this just said x first then, because it doesn't really hurt anything. If it said x plus 2 equals 14, we would look at this and say, I'm not going to touch this yet, and 14 is okay, but 2 is a lonesome number, and that needs to get kicked over to the other side. So I'm going to do the opposite to do that, which is to subtract 2 from both sides, which is exactly what they're doing. Now on this left side, the 2 minus 2 is going to go away to make 0, just leaving me this 3x. Meanwhile, on the right side, 14 minus 2 is going to change into 12. So now we have 3x equals 12. And now we'll work with that. This now is what we have just been spent the time studying in this chapter, how to undo a multiplication or division problem. Notice it says 3 times x equals 12, which is why it fits into what we've just been doing. I want to undo the multiplication by dividing at this point. Remember, x is okay because it's a variable, it should be on the left. 12 is okay, it's a number, it belongs on the right, but 3 is not. Right? It's a coefficient, not a constant, but it's still a number, and it's still got to get kicked over to that right side. So they're doing the opposite, which is to divide by 3. Multiplying by 3 and dividing by 3 won't cancel each other out and leave me variable x. Meanwhile, 12 divided by 3 changes into 4, which is the solution for x. Again, we can check this just like we've done every other time. The only thing that's going to be a little bit different about checking our answer here is we've got to make sure we use the order of operations. So 3 times 4 is what this is going to be, 12. That would be first with the order of operations. And then 12 plus 2 is 14. Since left side makes the right side, the equation checks. We'll conclude by looking at the various check it out questions. As you can see, the first two are more in the vein of the earlier questions in that they're just basic multiplication and division, while the fourth question combines the two once again. So in the first question, we've got half A, or half times A, equals -9. What you want to remember about this question, even though we already see the solution, we don't see the work, what you want to remember about this question is that this is a fraction. And as this question sits right now, it's a multiplication question. So to undo that, I'm going to have to divide. Right? But I'm dividing by a fraction. Well, we've never divided by a fraction, as we talked about earlier. We multiply by the reciprocal when we want to divide by a fraction. So to solve this one, what I'm going to do is multiply both sides by 2/1. Now on the left side, you can multiply the fractions across if you want to see it for sure, but it's going to make 2/2, which reduces to 1/1, which is just 1. And 1 times A just leaves me A when all is said and done. -9 times 2 is what I have to do on the other side to derive my solution. That's -18. If you want to write it as -18/1, you can, but of course that's just equal to -18. How do we check our work? Well, remember, you change A into -18, and you want the left side to equal something that's on the right side. Half of -18 is -9, and since the other side says -9 as well, the two sides are balanced. Let's continue on to the second question. Z over -3 equals 9. So we have Z, the variable. That's in the proper spot because variables belong on the left side of the equal sign. We have 9, the constant, the lonesome number, whatever you want to call it. It's in the right spot because it's on the right side of the equal sign. So we see the thing that's wrong is the -3. Notice I'm not marking this one up like we've done the other ones, but you can in your own note-taking guide if you want to. So I'm undoing the dividing by -3 by multiplying both sides by -3. Remember, I'm doing the opposite because when I want to move something to the opposite side, I do the opposite. Dividing by -3 and multiplying by -3 will cancel each other out and just leave me variable Z. Meanwhile, 9 times -3 is what Z equals, which is -27. Let's look at the third question. It's a story problem, and again, since it's in the section about solving equations with multiplication or division, there's a pretty good chance that that's what they're going to end up doing in the story problem. To purchase a new pair of running shoes, Dale has $30, which is only 1/3 of, notice I'm emphasizing of because remember that means multiplication, 1/3 of the total amount needed. What is the total amount needed? So, the amount needed is what we don't know. That's where your variable comes into play, because that's what we're solving for. So you can call that any variable you want. Since we're talking about Dale in this question, I'm going to use the variable D. It's 1/3 of the amount needed. So that's 1/3 times D. And we could just write that as a third D if you want to. That would, of course, be the same thing. And, of course, they'll then tell us that 1/3 times D is the same as $30, which is how much money Dale has right now. So this whole thing equals 30. So at this point now, we're looking at this and saying this is a multiplication problem. I'm going to solve by division. That's all true. D is in the correct spot, and 30 is in the correct spot. Variables on the left, lonesome numbers on the right. And remember, when I'm giving you those positions, it's all relative to the equal sign, left of the equal sign, right of the equal sign. So the thing I have to move is the 1/3. Well, if it's a multiplication problem, I'd be dividing by 1/3. Think about what we've seen. We just saw it a little bit ago in Check It Out number 1, and we talked about it quite a bit earlier. We've never divided by a fraction. To solve this, we're going to actually multiply by the reciprocal. The reciprocal, again, is the flipped form of the fraction. So if I flip 1/3, I get 3 over 1. So to solve here, I'm multiplying both sides by 3 over 1. On the left side, the 3 over 1 and the 1/3 cancel, which just leaves me D. And on the other side, I have 30 times 3 over 1, or just 30 times 3, which is 90. What does 90 mean? Well, that is, again, remember, the total amount of money that Dale needed. That's what we saw there at the end of that question. The question was, what is the total amount needed? The total amount needed is 90, as in $90. We'll wrap this up with the fourth question. The fourth question is asking us to solve the multi-step equation 4x minus 3 equals 17. So, we'll use all those same rules of solving equations, but remember I introduced a new rule to you when we did the similar question earlier, which said that the thing that's attached to the variable is x, and the number that's attached to it there is 4, so I'm talking about the 4. The thing that's attached to the variable moves last. So right now, that means that if I go through all the little steps that we do, that means that 3 is the first thing that's going to move. Here's 4x minus 3 equals 17. And we say to ourselves, variable on the left, x, numbers off to the right, 17. What's not so good in all that? The 4 and the 3. Both of those are numbers. One of them is a constant. The other one is a coefficient. Both of those got to end up on the right side. But again, the thing with the variable moves last. So the 4 is the last thing I'm going to do. Well, the only other thing to do is the 3. So I'm going to have to look at moving 3 here. Well, as far as moving things, remember all the other rules still hold. And the rule that applies there is that the opposite side, when I want to move something to the opposite side, I do the opposite. So that's where I'm going to go here. Since 3 has subtraction in front of it, I'm going to add 3 to both sides to make that happen. So when I do that, I get 4x equals 20. Notice the minus 3 and plus 3 cancels each other out and makes that disappear from the left side, as in the left side of the equation, left of the equal sign. So now I just have 4 times x equals 20, which looks a lot like what we spent today talking about. It's a multiplication question, so I'm going to solve by dividing out the 4. I know I'm moving the 4 because it's the number that's on the wrong side. All right, it belongs on the right, but it's on the left. So I chop out the 4 at this point, so I've got 20 divided by 4. 20 divided by 4 is 5. And as you can see, that does match our solution that was presented to us. We can check our work. We can do 4 times 5, which is 20. 20 minus 3 is 17. Since the left side of the equal sign is the same as what's on the right side of the equal sign, that's how we know we did this correctly.